Hello everyone, and welcome to the Kinematics Workshop. Today we will be teaching the basics of kinematics. This video was brought to y'all by WASMA. The Washington Student Math Association, or WASMA for short, is a student-driven 501c3 nonprofit organization dedicated to promoting the beauty and applications of math that are often neglected in school. Our goal is simple: to showcase how doing math can be fun and useful, and to empower students and math clubs anywhere to solve problems across all disciplines. Here's our table of contents for this lesson. First of all, we'll be talking about scalars and vectors. Next, we'll move on to a discussion of Suvat. After that, we'll be talking about the applications, and finally, we'll be discussing free fall as well as some practice questions. First of all, what is physics? Physics is a branch of science that involves heat, light, sound, electricity, and magnetism. It explains many of the things that surround us in our world.
What are scalars and vectors? A quantity that does not involve direction is scalar. It only has the magnitude, which is basically the quantity or numerical value. Some examples are speed, mass, work, energy, distance, and temperature. A quantity that not only has magnitude but also has a direction is a vector. A vector must have both magnitude and direction. Some examples are displacement, velocity, force, acceleration, and momentum. It's important that you understand the difference between the two. Displacement is not total distance. Velocity is not speed. Here are some of the important terms that we need to know. First, we have the distance traveled, which is the total distance traveled by the object. Because this is a magnitude without direction, it is a scalar quantity. Next, we have displacement. This is the distance between the object's final position and its initial position. Be careful not to confuse this with distance traveled. Because this is a magnitude and direction, it is a vector quantity. Next, we have velocity, which is how fast the object is going and its direction. As we can see, because velocity details the direction and scale, it is a vector. Lastly, we have speed, which is how fast the object is going, neglecting direction. Because speed neglects the direction, but has a magnitude, it is scalar. Before talking about Suvat equations, we have to know the definition of the term Suvat. S stands for displacement, which is the magnitude from the final position to the initial position. U stands for initial velocity, which represents the standing speed and direction of the object. V stands for final velocity, which represents the ending speed and direction of the object. A stands for acceleration, which represents the rate of change within every unit of time, which is usually known as meters per second squared or meters per second. T stands for time. How long does the motion take? Scientists and physicists typically use SI units for time.
These are one-dimensional motion diagrams, displaying an object at constant speed, accelerating, and lots of acceleration. These are some of the interactive resources you can try if you want to learn more about kinematics on your own time. It will be available in the video description box below. Here are the four main Suvat equations. They are v equals u plus at, s equals ut plus 1/2 at squared, s equals u plus v times t divided by 2, and b squared equals u squared plus 2af.
Let's take a look at the first Suvat equation, v equals u plus at. This equation gives us the instantaneous velocity of an object at a point in time. We can see this being applied to the example on the left. It states, a ball starting from rest at the top of a hill with an initial velocity of 0 rolls down with an acceleration of 2 meters per second squared. At 10 seconds, what is the velocity of the ball? We can see that the initial velocity of the ball is 0 meters per second, so we have u equals 0 meters per second. The problem also states that the acceleration is 2 meters per second squared, so we have a equals 2 meters per second squared. Lastly, the problem asks for the velocity of the ball after 10 seconds, so we have t equals 10 seconds. Plugging these values in to the Suvat equation gives us v equals u plus at, v equals 0 meters per second plus 2 meters per second squared times 10 seconds, v equals 2 meters per second times 10, and finally v equals 20 meters per second. Thus, The velocity of the ball after 10 seconds is 20 meters per second. Next, we have s equals ut plus at squared over 2. This equation gives us the displacement of the object. Now, because this equation doesn't have the variable v in it, we can see that the final velocity is not needed. We can see this applied in the example to the left. A runner starts running with a speed of 5 meters per second. If he accelerates at a speed of 0.5 meters per second squared, how far would he have ran in 10 seconds? We begin by first identifying the variables presented in the problem. We see that the initial velocity, or u, is 5 meters per second, as the runner starts running at that speed. We also see that the acceleration, or a, is 0.5 meters per second squared, and that the time elapsed, or t, would be 10 seconds. These are all the variables we need to find the displacement, or s. By plugging these values into the equation, we get s equals 5 meters per second times 10 seconds plus 0.5 meters per second squared times, in parentheses, 10 seconds squared divided by 2, which gives us s equals 50 meters plus 0.5 meters per second times 100 seconds squared divided by 2, which gives us s equals 50 meters plus 0.5 meters times 100 divided by 2, which gives us s equals 50 meters plus 50 meters divided by 2, which is s equals 50 meters plus 25 meters, which is s equals 75 meters.
The Suvat equation s equals u plus v times t all over 2 is another way to calculate the displacement of the object. This can be used when the acceleration wasn't given in the problem, but the final velocity was. This can be applied in a question like the example to the left. Let's take a look. So Carmen rides a motorcycle to work. However, she notices that she's gonna be late. She starts at a fast 30 meters per second velocity, but accelerates to a 40 meters per second velocity through her 10-minute long ride. So what's the distance between her start location and her workplace? First, we have to identify the values of the variables needed to use this equation. We can see that the initial velocity is 30 meters per second, the final velocity is 40 meters per second, and the time is 10 minutes. And we're trying to find out the displacement. Notice how the velocities are in meters per second, so we have to convert the time unit from minutes to seconds. Now how do we do that? Well, we know that 60 seconds is in 1 minute, so we multiply 10 minutes by 60 seconds divided by 1 minute. So the units cancel out, and you're left with 600 seconds. Now we can plug in the values into the equation. So s equals 30 meters per second plus 40 meters per second times 600 seconds all over 2. That should leave us with s equals 70 meters per second times 300 seconds, which will leave us to s equaling 21,000 meters.
Finally, we have the equation v squared equals u squared plus 2as, and we can derive this from the equations we were already given. V equals u plus at, and s equals the sum of u plus v times t divided by 2. From the equation v equals u plus at, we can represent the final velocity squared as v squared equals u squared plus a squared t squared plus 2uat. From the equation s equals the sum of u plus v times t divided by 2, we know that 2as is equivalent to 2as equals the sum of u plus v times at, or 2as equals uat plus vat. From this, we can restate the equation v squared equals u squared plus 2as in different terms through the process of substitution. And the equation thus becomes u squared plus a squared t squared plus 2uat equals u squared plus uat plus vat.
Okay, the initial and final velocities of two different cars with constant accelerations are respectively -10 and +20. The first car has displaced 25 meters. Okay, 25. So we know that's Suvat equation. So 20 is equal to 10, negative 10 squared plus 2a and displacement of 25. So since we know that that's 400 and that's 100, so 300 and then 50, right? So acceleration of that is 6 meters per second squared. Okay, the first question was easy. Let's look at the second question. Challenge. The second car travels a total distance of 20. Could you find its acceleration? Okay, so since we know that the initial velocity is negative, so it's going this way, and it stops and it goes forward. So let's say this negative distance is equal to s1 and s2. Okay, so since we know the Suvat equation, and then s1's final velocity is 0, so 0 is equal to, and u, negative 10 squared plus 2a, and then since it's going this way, it has to be negative s1, and then we get negative 100, and since it's negative 50, so s1 is 2, so it's 50a over s1. Okay, 50a over a is equal to s1. Okay, let's try the same analogy here. So since s2 is positive, we don't care about that. So it's 2a s2 plus initial velocity is starting here, so 0, and final is 20 squared, so 400. So divide by 2, you get 200. A is equal to 2s. So since the total distance is 20, so 200 plus 200 plus 50, so 250 divided by a is equal to 20. So we can take reciprocal, and then gives us a. So a is equal to 12.5 meters per second squared. All right, thank you so much. Have a nice day.
Thanks for watching. We hope you enjoyed this video. If you are interested in joining WASMA or want more info, you can contact wasstudentmath.org or visit www.wasstudentmath.org to reach out to us. This link can also be found below this video in the comment section.